there's probably a few more trickling down. People are still leaving the gym. I'd give it maybe just a couple more minutes.
All right.
People are kind of getting all their stuff together. So they're on their way.
Sounds good. Well, we're just going to wait a few more minutes, see if anyone else shows up. I don't know if their stragglers or So, does anyone actually have any experience with RotbotC? Alright, nice. So, this is basically just a quick overview of the basics. I'm Malavika, this is Jared, and we're on Swerve, we're part of Swerve Robotics. Alright. Well. Alright, we can go ahead and start. I don't know if anyone else is coming. They can catch up. Alright. So, we're going to basically start with just setting up RotbotC since everyone's new to it. So I'm assuming you've all downloaded RotbotC and stuff, so hello. So basically just open it up. And it takes you to a screen that looks like this. And you want to make sure you set your menu levels correctly to super user. And you also want to make sure you're on NXT plus Tetris and Matrix platform type. Alright, so then you can open up your files or start a new one. So. Alright, so when you open up a file, it just gives you task made, and over here we have a single line comment. And so we're going to start off by showing you how to set up the pragmas in RotbotC, which basically just configures the motors and the servos. So you go to motors and sensor setup in the robot menu, and start off with external controllers, and you can just put basically just match the wiring on your robot with your motor and servo controllers. Alright, and then have motors accordingly. And so reversing one just reverses the polarity so that you can set them both to 100 and they'll go straight. And you can give them encoders so you can read encoder values off of them. And don't need to reset this right now. And so that it'll automatically generate the pragmas. Don't try to write them yourself, because that doesn't end well. You can copy and paste between your codes, or between your programs, but don't write them yourselves. And, alright, so we're going to start off with teleop. So with teleop you need joysticks. So you want to include the joystick file. You want to include the joystick driver, which gives you access to all the different functions so you can get the joystick values and the buttons and all those states. So you also want to use comments in your code that tell you what they all do. That's an example of a pretty good comment. It tells you what the include file is. So over here we have a couple don't have to set it equal to anything. Useful variable names, not fill. And so, does anyone have any questions on that? All right. So, why don't we go to case statements? Alright, so over here we have if statements. And an if, it's basically like if the thing in the parentheses is true, then do whatever in the squiggly braces. And so in this case we have vote does not equal, that's what the exclamation equal means. There's also less than, greater than. So that's less than. That's greater than, less than or equals to, greater than or equals to. And equal, which says if the two things are equal. If you put one equal, then it'll set it equal instead of comparing them. We also have else ifs if you have multiple things that you want to compare, and just else's if nothing else in that is true. Anyone have any questions on that? Alrighty. So then if you want to do any of those multiple times, you would use a loop. So we go down to our basic for loop. And so in that you have, and so basically you just iterate through the loop multiple times. And so you start off with a starting variable to start off, and then your condition to continue the loop, and then what you do at the end of each loop. So in this case, you have this variable I, which is called 0, and as long as I is less than 10, it will continue through the loop. So, and at the end of each loop, it'll increase it by 1. That's what the I++ means. So the loop will run 10 times and do whatever's in the braces, which right now is nothing, so it'll just run 10 times. This while loop does the exact same thing. It's just a different way of writing it. Generally, when we're writing code, we want to put everything, the main block code, inside a while true loop, which put that. True. And that is an infinite loop, which is generally terrible programming practice, but in for FTC, it makes sense because you want to run through everything constantly, and you want it to end when the field control system tells it to end, not before then, not after then. So while true loop tends to work for that. Okay, so then we can talk about functions. Oh wait, does anyone have any questions on those loops? It's kind of difficult to wrap your head around that logic. Okay. So functions. Alright, so over here we have a function. And a function is used to make your code more readable and faster. Because if you're writing a bunch of code like in your main task, then it gets really confusing when you have all these different things. So you can take some of it and move it out into a function. Then it makes your code more readable and it's a lot easier to understand what's going on. So here we have a function, and the bool, so the func is the name of the function, and int x is what you pass in. So whenever you want the function, so if you want the function to have access to one of your variables that you've created, you have to pass it in, and it returns a value, or it doesn't have to return a value. Over here, right now, this is returning the Boolean fill with the return statement here. But if we change the bool to a void, then we don't have to have a return statement. It'll get mad at you if you have a return statement. So then it won't return anything, it'll just do that. But if you want it to return something, you have to have a return statement. So generally, it's best to start off with planning out your functions before you start writing all your code, because going back from your code to making a function competition, you want to get joystick settings, and you want to put that in your infinite loop that you have going on so that it reads through it every time. You might want to put that in the other one that's like empty. So when you have your infinite loop that's constantly reading through it, you want it to get the joystick settings every time so it can track changes in it. And so once you have that, you can call them, go down to where it's called. Yeah, over here. So so you can, calling the joystick like that basically calls the X value of the first joystick. There's lots of different ways to get the joystick values. I'm not going to go over those right now, but you can look those up online with the documentation, or just look through the joystick driver file. So this code takes the absolute value of the joystick value, yes, the joystick value, and compares that to the dead zone to see if it's greater than the dead zone. And so basically that just takes a 0 and it sets the motor value to the joystick value. There's also all the buttons and the D-pad that you can use depending on your purposes with your motors and such. If you want to move a motor, you put motor square brackets in the name of the motor and you set it equal to what you want it to be, so that can be like a function or something that, anything that comes down to being an integer between -100 and 100. You can also set servo values similarly. It's a similar definition, but the servo values are between 0 and 255. There's the standard servos, which are positions, and the continuous rotation servos, which are just like little motors, but you can't use any motors on them, and they're a lot weaker. So if you want to use a timer in your code, that's very useful if you have stall code, which detects stalls, or just to see how long it takes. It can be useful for debugging. You want to start off by zeroing it at the start of your program, or start of your main task, and then you can read it and do what you will with it. And when you, so you can set it to a variable and then use the variable to do something. With encoders are generally more useful for autonomous than for teleop, but you can still use them for teleop. So basically, endmotor encoder write tells you the encoder value of the write motor, and here it's comparing it to, it's inside of a while loop, so it's comparing it to 1440. And 1440 happens to be the number of encoder takes in one revolution of the motor. And so that little chunk of code basically just makes the motor turn one revolution. And so that can be very useful for accurately determining distances in autonomous, as long as you factor in your gear ratio and stuff like that. So we can also talk about sensors. And so this is with a touch sensor. The other sensors are called similarly, but we'll just go over touch sensor right now. So touch is the name of the touch sensor, and sensor value just tells you what value that's outputting. And so with touch sensors, if it's 1, that means it's pressed, and if it's 0, it's not pressed. So this piece of code says that if the touch sensor is pressed, then it will set the right servo to position 50. Anyone have any questions over motors, encoders, servos, and sensors? All right. And then we can also have multiple tasks. If you notice, all the code that runs is in the main task, which is the code that runs right away. And that's how you designate to the compiler that that's what you want to run first. And you can also add other tasks, which you can use simultaneously. So if you want to put your joystick if you put your drive joystick code in the main task, and then put your mechanism joystick code in the other task, that tends to split them up so function, but you write task in front of it and you name it. You don't pass anything into it. And you can just put whatever you want in the task, generally the code for running the other joystick. And when you go to your task main, you have to make sure you start the other task, otherwise it will not run. And so that way they'll both go on almost simultaneously instead of conflicting with each other. Does anyone have any questions about that? What?
What do you mean by conflict?
Well, Jared, do you want to talk about the problems you had last season?
Yeah, so last season we had both the joysticks in the task main, and while our lift was going up, we couldn't get values from the controlling joystick for the motors and the wheels. So we would continue going forward until the lift got to the position that we wanted it, and then it would stop going forward, so we would randomly hit the wall or pin other robots. So I had to change it to random task.
So that's
Yes, they're separate threads, yeah. Because what the problem Jared was having was that it was stuck in the while loop for moving the arm up, so the driver couldn't access anything because it wasn't reading that part of the function of the code. So if you split it up, then it'll run separately. So does anyone want me to repeat anything that we just gone over, or does anyone want to sort of try things out on their laptops? Do you have laptops? Okay. Well, I mean, if you just want to sort of try things out or go over stuff.
Yes.
So, if you set, so there's some code there that you wrote something to a motor or something, to turn a motor on. What did the values mean? So,
Over
what is,
here.
yeah, well, I can't read that through that, so so what range of values do you write to the motors and things like that to get it to move?
Right, okay. So motors go from negative 100 to positive 100. The negative is just the direction of the motor, and the numbers are the power values. So if you set it to 0 to stop it, you have to make sure you set it to 0 once you're done with whatever you want, otherwise it will just keep going at whatever power you last told it to go at. And so the joystick values go from negative 128 to 127. So generally you want to map that down to between a negative 100 to 100, depending on how you want your controls to be. I mean, if it's over, it'll just like stop at 100. And so even if you give it 128, it'll still just be 100. And so depending on how much sensitivity your drivers want, you would change that. But does that answer your question?
Yeah.
Okay. Does anyone else have any? Okay, yeah, we can go over using buttons.
Well,
Yeah.
so the joystick controller has a bunch of buttons on it.
Mm-hmm.
How do you get the information from the buttons on the joystick? Or not joysticks?
The buttons, yeah. Well, Jared's gonna just sort of show you. And so this gets the button 7 off the first joystick. All of the buttons are numbered from 1 through 12. There are like 12 different buttons on it. And so they're not very usefully named in the code because it's just the numbers. But if you have like a joystick, you can map it to that. Also, if you run the debugger, it tells you which buttons they are. And so basically, and the equals 1 is it pressed or not, because buttons are either 0 not pressed or 1 pressed. So kind of similar to the touch sensor. And so you just call it like that. And so basically, if that button's pressed, then it'll set the right motor to 100. And if you want it to stop, you would
it seems to have a mode button on it that changes it to different modes. As well, it seems like you can't get the front triggers as well as both of the joysticks. Is there a way to get all of the buttons, all of the joysticks, all of the, like the front triggers seem to be in proportion as well as the joysticks. Is there a way to get values of both of those? Because actually, we've been playing with it and we only get like 2 of the joysticks at any time. Does that make sense?
And
So the front triggers
Yeah.
are proportional, right? How do you get the, what do you use to get the proportional front triggers versus the 2 joysticks?
well, the triggers, you would treat them just like all the other buttons.
So they're buttons, they're not
No.
proportional? Oh, so they're one of the buttons?
Yes.
Okay.
So you have, yes.
So there are 2, for the teleop mode, there are 2 joysticks for the game. Do you see this conceptually as a single joystick controller where it sort of puts all the controls together, or do you need to differentiate between?
Yeah.
Yeah, that's a very good question. Okay, so when you're calling them like that, the Joy 1 tells you which controller it is. There's the first controller and the second controller because you have the 2 drivers, right? So if you change that to a 2, then it goes to your second controller. And generally the first controller is your drive controller and the second controller is your mechanism controller. And so then you also have the X1 and X2. And so you can change the X to an X or Y, and that reads it this way and this way. And the 1 and 2 say which joystick it is. So 1 is the left one and 2 is the right one. So if you just change those around, then you can get all the different values. Yeah.
You mentioned some other sensors. You said something about another sensor, like a touch
Right.
sensor.
Yeah.
How many other sensors are they, and are there, and how do they connect to the system?
Well, there are lots of other sensors. There's a whole list of them. Like the most common ones are the IR seeker and the touch sensor and the ultrasonic. Those are the ones that I personally have the most experience with. Actually, the ultrasonic was a while ago, and so there's all these other ones too, like magnet, compass, acceleration, gyro. Tons of them. Yes.
Gyro, have you used it? Do you get it to work? Is it consistent?
We started playing with it a bit over the summer, but we haven't.
We don't usually use it.
Yeah.
Just those first 3 that you named, the ones you guys usually use.
Yes, we use touch sensors the most, and we started with IR sensors last year, and I played with ultrasonic sensors a bit the year before. Touch sensors are generally the easiest to use because they're just another button, but you call the other ones similarly. Like, do you have an example of that from your autonomous from last year of the IR?
Oh, yeah.
Will you open that up?
While he's doing that, how much code can you get on an NXT? They're kind of small for,
Yeah.
right?
I don't remember the exact number, but generally, like, we haven't had any issues with it not fitting. Because generally you can get all the programs that you want on it, because these aren't very large programs.
Okay.
Because you just have your teleop, your autonomous, your standby stack, and your program chooser. And there's always plenty of space for that. And I personally have always included programs to put like the lift down or like judging demos like on top of that. So there's plenty of space.
Okay. Another question?
Oh yeah.
Yeah, the NXT's got some like ports on the top and ports on the bottom. What do all those ports? How do those ports get connected via code?
All right. Well, the ports on the top are the letter ports, A, B, and C, and those are the Lego motors. And the ports on the bottom are the numbers 1 through 4. And so those you can go to controllers or sensors. And so yeah, so the S 1, 2, 3, and 4 ports over here. So you can put
when I say motor, how do I get one of the things that's on the Tetrix controller versus the one that's on the Lego
NXT controller.
board at the top?
You use them the same way, they just have different names.
I see. Oh, what do we have?
And so up there it's the progress that RotbotC defines. And so if you go back to the motors setup, so motor A, B, and C are the NXT motors, the
Right.
Lego motors that just plug in. The FLL teams use those a lot. And then the motor sensor port 1, controller 1 is the one that's on the actual motor controller.
I believe if I'm right, that you named it left and right.
Yes.
That name, you can make anything to refer to it in the code. There's the mapping from whatever the physical connection is to the name. You could call it wheel motor or happy motor or whatever.
Okay.
So that's the connection right there.
Okay.
So kind of checking, I think I understood what you guys just said. It's actually in the setup that you tell the software what you want to do, and RotbotC behind the scenes takes care of writing these little methods that take care of connecting the code to that particular correct mode.
I believe it shows up in
So
the
the
header,
pragmas
doesn't it?
do,
That's what
yeah.
you're telling us right at the start, I think.
Yeah, is that it right there?
Yes,
That's the
the pragmas. It's a lot, so much easier to just let RotbotC write them and to actually write them.
Your highlight, we can't see.
yeah, the highlight doesn't work.
Actually, if you double click any of those names, it takes you straight to the configuration.
Nice.
You don't click the top of your file.
So there's the left and the right there.
Yep. And so then you can also put in however many servos you want. And so each motor controller has 2 motors, and then each servo controller has 6 servos that you can plug in.
Did you talk about servos? Sorry, did you talk about how
Yeah,
servos
we talked about it a bit. We can go over this.
No, I was just curious.
Okay, yeah.
Each motor controller has 2 motors that you can chain motor controllers.
Right.
So you can control the motors.
With, yes. Last year we used 6 motors on 1 controller by just wiring them all together. That was the only challenge with that. I was just getting all the motors in. So, in the code, they're just treated separately. Yeah.
So, again, new startup person, this year you're anticipating roughly how many motors, how many sensors, how many little motors, how many big?
Oh, okay.
So how is this about what you expect to be doing this year? Motors and sensors and controllers and so on?
Yeah, generally you would have one motor controller with your left and right side of your robot, and if you're going for tank drive, that's enough. And when you're physically putting in the motors, you usually want to have 2 or 3 per side, at least 2 I would recommend. And so when you have the wires for that, you plug them both into the same port on the controller, so the software treats it as 1 motor, even though there are physically 2 motors present.
That's for redundancy,
Yeah.
in case something breaks.
Well, and also it'll go faster if you have to. Yeah. And so, and servos, usually you'll use them if your mechanism demands it, and same with sensors. So like an IR sensor would be good to have for the autonomous this year.
Okay.
I guess we can talk about the wait to start. Open up your
Oh, yeah.
direct code from last year, your teleop code. designate which one's your teleop program, and then the FCS runs that. And if you don't have the wait for start, it'll just start running before they're ready.
Do you, so you use different program files for your teleop versus your common?
Yes.
Why didn't you like use the two while loops and try to program it all in one?
Well, you could, but that would be pretty confusing. So it's best to have them separately. And if you look at the code that like comes with the FTC package, you know that like teleop sample code and common sample code. It's somewhere. Open sample program? No. Open sample program. It's there somewhere. First stick challenge. So open up autonomous and teleop. There's two of them. Autonomous is up there, teleop's down there. So just open them both up. And so this basically just gives you a temp and teleop. So you want to make sure that you're so like this just gives you a template to start off from, and you want to make sure you have all the stuff like we don't have to have the initialize robot function, but it's generally good practice to have that so you can sort of give your servos a starting position and like calibrate or whatever it is you want to do there. And so similarly with teleop. So if you go down to the main task, right, so you call your initialize robot function, and then you have the wait for start, and that just basically, and then you have your while true loop where you put all your robot code and your joystick values and all that stuff. If you go to the main task for the autonomous program, it has basically the same thing, except you don't actually use the joystick. You only include it at the top because the wait for start command is in the joystick driver, but you can't use joysticks in autonomous. So it's good practice to start off with your teleop program and get that working with your robot, and then sort of move on to autonomous after you get reliably driving. Yeah.
When you're having like a competition, is there a way for this to be checked out before you actually start the game, your session? Does you check your robot in with a system or something?
Oh yeah. There's And so that's the code that we wrote. So some of it's slightly fishy, and some of it's been well tested. On what?
That's what we've done.
So for us, the joystick, the code was easy.
Yeah.
It was getting the joystick to actually work with the computer and how to use it. Can we go over that with you? Because to use it directly with the with the RotbotC versus SAAS and stuff for practice, what do you have to do to get joystick working?
Oh, okay. Well, if we bring
You probably don't have a
We
joystick.
don't have any joysticks.
I can get some steering wheel.
yeah, that's what it
Yeah.
is. Well, yeah.
You want to just write down what we have all ours.
Because we did
Wait, no, don't.
I can get one of steering wheel.
Okay, yeah.
XT.
Yeah, that way we can sort of like show people the debugger windows and stuff.
I think we only have about 5 minutes.
Okay. Then,
Is it 9:50 that we're doing this?
I think so, yeah.
We're getting a little low on time.
Okay, yeah.
Maybe in the afternoon
Well-
build session, we can show it off.
Yeah.
In the afternoon, oh, you know.
Yeah,
you want
if you
that
want to
all-
stop by like our pit tables, 417 and 6220,
We
will.
were getting it. Just wanted to
Yeah.
point out that that was much harder than actually the code. Was getting the
Yeah.
joysticks working and figuring out the tools you have to use.
Yeah. If you open up the joystick driver,
If you're unsure about that stuff,
No, we got it going. I just got
I
other
mean,
stuff.
if you're figuring out how to get it going, like, I just found a YouTube video
Yeah.
and watched it.
You ever run out of gears?
And there's also the difference between the mode buttons and doing a different things.
right, the mode button just swaps the D-pad and the left
Right.
joystick.
So that was confusing the way that.
Right, so
What it
you
actually-
want the light to be off.
There's nothing that says that.
Yeah, we noticed that when we were doing our outreach robots, and all these little kids kept pressing all the buttons. So of course those buttons got pressed, and they were like, it's not working. And so when we went back and like looked at it in the debugger, when you have the joystick, it tells you which buttons are being pressed. So we pressed the mode button, and we noticed that like it took the D-pad and it was reading the joystick values, and it was treating it like it was a joystick.
Yeah, we found those are